Hello class, I'm Askbeard from Askbeard Consulting, Indonesia. Today, we'll talk about drought analysis using normalized difference drought index using Google Earth Engine. Before we begin the practice, some people are still confused between the Google Earth Engine and Google Earth Pro. So Google Earth Engine is different from Google Earth Pro. The Google Earth Pro, it can only for spatial visualization, but you cannot do a spatial analysis on Google Earth Pro. You just can see the place, see the view, but you cannot analysis using Google Earth Pro. Meanwhile, Google Earth Engine, you can combine the dataset, you can do spatial analysis, and you can do spatial visualization in Google Earth Engine. However, the main constraint of using Google Earth Engine is the use of language programming because it is based on JavaScript. The main constraint of JavaScript is case sensitive. This means if you are having a typo on some function, then some function cannot be run properly. For example, if you want to use vocal underscore min, but you forgot the underscore, or you do not use the capital letter, or you use the capital letter for this function, then the function will not be run properly, or it will become an error. So what are the steps for the drought analysis using Google Earth Engine? The first main step is you have to register to Google Earth Engine. You can follow the steps shown in our YouTube video to register for Google Earth Engine. If you already have a Google Earth Engine account, then you can create a username. And you cannot change the name of your username after it's created. And then after you have the username and you have the account, the third step is we create repository and file. Repository is like a container for our file, and our file consists of script for analysis on Google Earth Engine. And then after we already have the repository and file, then we define the area of interest. And today we'll talk about Peatland. We use the global Peatland map data from the UNFCCC, and then we visualize it, and then we choose the area of interest for the Peatland area that we want to analyze. After we choose the Peatland area, then we define the area of interest using the rectangle button on Google Earth Engine. So the basic of drought analysis is based on the normalized difference drought index analysis. The NDDF values has a formula which is based on the NDVI, or normalized difference vegetation index, and normalized difference water index. So it combines two index to define how severe the drought on the area. The NDDF value, it can be under -1, it is on normal category, and then -1 to 0.15, It's called my drought, and then 0.15 to 0.25, it's a moderate drought, and then 0.25 to 1 is called severe drought, and over 1 is called very severe drought. And the NDDI analysis, we use the harmonized sentinel of the spectral instrument data. Before we use the sentinel dataset, the clouds from the sentinel data must be removed. And then after that, we can use for the analysis based on the following formula. After we have the NDDI data, we can classify it using the classification of the category based on the value of the NDDI. Okay. Okay, without further ado, let us go to the code.engine.cool.com to begin the analysis. Today, we want to talk about drought monitoring analysis. The first step after we have an account and already have an account name is create repository and file. We can click new and then we can click repository, and the repository names must be unique and cannot be changed. And then it should not be any space. You can use the dash or the underscore, and must start with letter. Let's say the name is EA on Peatland, and then we click create. See, you cannot use any space because the repository names must start with letter, which already have, but it only can contain letters, numbers, dash, or underscore. We cannot use space for the repository name. Let us change to use underscore or dash. Then we click create. After we already made a repository, then we can find the repository is empty. We can fill the repository using new and then file, and then we choose the NADI Peatland, and then we enter the name of the file. Let's say we name it as script for NADI on Peatland, and then we click OK. So for the repository, you cannot use any space, but for the file name, you can use space. You can see this, the name of the file, the script NADI on Peatland. You click, then it will change from the new script to script NADI on Peatland. Okay. So we go to the next step. We will visualize the global peatland map data. We use the following code. It is the global peatland database based on the NFCCC. Let's say we name it as global. If we want to visualize the data, we can use the map layer and global. And then we click save. And then we click run. You can see the black one is the peatland data all over the world. Let's say we want to talk about peatland on my area. Let's say on this area. How do we define the area of interest? Let's say we only choose this area, this small area. Let's say this. And you can change the area later by track the geometry. Let's say from this to this area to this area, or maybe on another island, or maybe on another country. Yeah. Okay. After we define the area of interest, you can stand, you can change the name of the geometry, maybe from geometry to area of interest, or we can abbreviate it as area of interest or AOI. And then after we define the area of interest, then we use the Sentinel data to begin the analysis of NDDI. First, we search the harmonized Sentinel to MSI, use the level 2A, the surface reflectance data, and then we can click the view dataset indicator of page. The first step is to copy the Earth Engine snip, and then we name it as the Sentinel data. And then we define the bounds or the area of interest. Then let's say we want to talk about the area from the 2025 data. From the 1st January until, let's say, the 1st October. And then to get the cloudless Sentinel-2 data, so as the NDDI data will be good, we have to remove the cloud from the Sentinel-2 data. To remove the cloud from the Sentinel data, we can use the scene classification map bands. Let's say we name it as the same as the bands. And then from the scene classification map, we can go to the class table of the scene classification map. We then choose the third, 7, 8, 9, and 10 value of scene classification map. Just the cloud shadows, the cloud slopability, clouds medium, clouds high, and cirrus cloud. We want to remove all related to the cloud on the Sentinel-2 data. We define the third of the STL, and then the 7 and 8, 9, and the 10 class of scene classification map. And then we mask the cloud using the update mask function to 0. And then from the 1st January to the 1st October, we should find the best pixel. The best pixels must contain many number, digital number of pixels just by choosing the median data. And then we want to visualize the Sentinel data by define the Sentinel. And then we click run. So the first layer is the global Peatland map data. And then we can uncheck the geometry imports. We can see it is still has no color. We can define the color by choosing the RGB bands. The RGB bands on Sentinel-2 is based on the fourth band, the third band, and the second band. So I change the 4, 3, 2. And then we stretch to define the digital number for the visualization of data on that area. And then we click apply. So this is the area with the best pixel value from the 1st January to 1st October. And then we import the visualization parameter. And it will has the name image visparam, which is the visualization parameter for the Sentinel data. We can define it on the Sentinel function. Okay. So what is the next step? Next step is we define first the NDVI formula. The NDVI formula is near infrared of the Sentinel-2 and then the red band of Sentinel-2. We use the formula, and for the normalized difference water index, we use the near infrared and shortwave infrared one. So first we use the NDVI first. How do we define the near infrared and red on the Sentinel data? We use the normalized difference function, which already has on commentaries of Drought engine. And the formula is the same as the NDVI formula. We just define the number of bands of the near infrared and the red bands. So the first band is near infrared. It's on Sentinel-2 data. It's on the 8 bands. Then the second band is the red data, the red bands. It's on the 4 bands. And for the normalized difference water index, the code is still the same, but we just change the number of bands because we use different bands. The near infrared is on the 8 bands and shortwave infrared first is on the 11 band. Then how do we define the normalized difference stop index? You can just use the formula, which is NDVI, and then we subtract it by water index, and then we divide it by the sum of NDVI and water index. Okay, so to visualize it, we use the map layer NDDI code to visualize the NDDI data. We can click the edit layer properties, and then we can define the minimum until the maximum data right on the layer. So it's from the negative 0.048 until 1.079. Let's say it is from the green until the red one, or severe drought. So the green one is the normal data, and then the red one is very severe drought on the area. We can save the data. You can click import, and it will be named as image whisper 2 because it's the second visualization parameter after the sentinel data. And then how do we classify the data? Let us name it as classify NDDI. So under -1, we name it as LT or less than -1. It's called the first class. And then the greater than equal from -1 to 0.15 is called mild drought. And then for the third class, 0.15 to 0.25. And from 0.25 to 1 is the fourth class or severe drought. And then we define over 1 or greater than equal 1 is the fifth class or very easy for drought. Okay. Okay. To define the color of the data, it is from 1 until 5. It's already in line with the classification. And then we choose the color. from the first class until the fifth class. Let's say from the green until red. So the higher the drought or the severe the drought, it will be red. And we click apply. Then we click import. Then how do we get the statistical value or the mean value of NDDI on this area? We use the reduce region. And then we define what reducer we want to use. The reducer we want to use is the mean reducer. Just the statistical tool to get the mean of the data. There are many reducer on Google Engine, let's say from mean, median, max, both. And we want to choose the or to define the mean data. After we define the reducer, then we want to define a bounds of the area, which is the area of interest. And then the scale, the scale is the resolution of Sentinel-2, which is 10 meters. Then we can click save and run. And then at the end, if we want to save the data, we can use the export image to drive function. Let's say we want to save the NDDI data. Choose the for NDDI, and then we define the region, which is the area of interest. And then the name of the file, Let's say we define the file name will be NADI data. And then we define the resolution, which is based on the resolution of Sentinel data is 10 meters resolution. Then we define the coordinate reference system. Coordinate analysis is to use the global coordinate system based on the EPSG 4326. Then we can click save, and then we can click run. To save the data, there will be a task. There is an unsubmitted task. You can click run, and then we can click run. Okay. So the mean of the drought of this area is on 0.39. Is on severe drought. Okay. So in the end, the most important thing is the link of the earth engine code. If you want to use this link and then you want to replicate the code, you just have to go to this link and let's say go to the link. It will be the same as what I've already done on the earth engine on my script. Let's say you want to change the area, not this area, but let's say on this area. You just have to drag the area. You click the geometry imports, click the area of interest, and then you just drag the area, and then you just click run. And then all the data will be adjusted to the area. Let's say the sentinel visualization, and then the NDDI data, and then the NDDI classification. It will be the same, or it will be adjusted to the area of interest. Let's say we want to change again the area of interest. Let's say we want to drag it on this area. We just click run, and it will change all the data. So the most important thing of this training is the code. You can use the code and then you can replicate it on your area. And on this area, the drought index is higher, which means the droughtness of this area is more severe than the area that we already analyzed before. Okay. Okay. And this is the end of the training session. I'll express gratitude for joining this training. Thank you and good evening.